So hello everyone. In this video, we will be working on Little Kernel. So it's my journey for the Micromax. I want to repair my phone, and for that I need Little Kernel. So I have most of the things here. There the Android scatter file, instruction sets, and these things. So I have Little Kernel here. This is Little Kernel master, and this is another fork I found on the internet. Let's check the Little Kernel first. Let's try to understand how it works. So I have Little Kernel repository open there. I think you are able to view it, right? Yes. Okay. Embedded operating system. Okay, say for the latest version, comprehensive document, it's the index. Let's say index Cortex M. Okay. Probably we have this one of these two. Scripts completion.h. Okay, I have Little Kernel fps. Okay, git clone cd scripts fetch toolchain prefix. Okay, let's see if we will be able to build it. Okay, fine. Okay, we are here. This is the forward one and this is the original one, master. So I'm going to master and we'll try to open terminal here. There's my terminal. Okay, there are two terminal now. So let's close the first one as I don't need it. Mm, First clear this thing. Clear. Okay. And type WSL first. I'm starting the Linux. Okay. I think it's started now. Just make clear. And we have LK master. And if I do ls minus l. Okay, we have readme.md. Let's try to readme.md. Readme.md. And it's written the same thing, right? Okay, but how we build it? I think make is installed. Let's check that. Make. Okay, error directory make lk master. Entering directory pv. Okay, engine make no project is specified. Use make list for list of projects or make help for additional help. So make list. Hello, make host. Sorry, list. You have this one. All buildable projects. Look into the projects directory. Okay. Here is there is any projects? Okay, project directory. Okay. Okay. So we don't have any QEMU, right? Spico, Pico test MK and PC86. Roscoe RPI. Okay. Let's check some online documentation if we can find something. Okay, let's check something. Building a little kernel from source code. Okay, here the AI recommendation. Sudo git install build essentials. Live uses dev QMS systems ARM and it's trying to install all this. Clone the source CD, LK build the target project, QMA virtual ARM64. We need to build this. Okay, first we have to install the build essentials, I think. Copy. Let's to clear it again. Clear, paste, and check sudo apt install get. I don't want any git to be installed. Build essential lib causative. What is the what this does? What this does? Why? Mm, okay, it will provide me the response. QMA system ARM. Okay, leave SSL dev. Okay, SSL development. GCC ARM none EABI. GCC architecture chain Linux chain EABI. Okay, the package is a legacy visual library often found in older embedded tools and documentation. For modern compilation of the little kernel, it is really completely unnecessary. Included Y and safety to driven menus. Many operating system Linux make terminal-based UI to let users select multiple options. This menu layout depends entirely on text graphic library. Okay, that's fine. I think rest we need to install. Just press enter now. Password is so download size is 708 megabyte. Pressing enter and it started downloading. Let it download. Okay, little kernel LK master. This make and kernel. I think the actual kernel is this. That should be main C. Okay, it's written in C. Include. Okay. This is GitHub architecture dev. Docs external kernel library make platforms. Okay, there are more than platforms. Okay, this for these platforms we will be able to make something. I think make the kernel. Okay, we have agents here. Engine dot make file. Okay, top two tools. We have bin to H and net tools. Network C LK boot. Okay, and we have the Rust thing. LKSS. Okay, for someone beginning, it's really hard. Okay, we have the documentation also. Getting started. Okay, we have the documentation here. Index of index. I think we need to carry this file. Edit on Notepad. Okay, edit with Notepad++. I should be able to open it. Okay, ignore this. Welcome to the LK documentation. LK is a small operating system designed for embedded system, offering a lightweight kernel with threading memory management. Threading memory management and device drivers. Table of contents. Getting started.amd. To do AMD. Current development task and known issues. Threading and scheduler system. Blocking primitives. VMM overviews. Source tree structure. Structure of the LK source dependent. Okay. Platform is specific to ARM fixed virtual platform. Architecture overview and supported architecture. ARM backs open risk. Supported platforms. QEMU ARM fixed virtual platform. Various embedded development boards. Custom hardware platforms. Key features real-time capable. Okay, install or build recent version of QEMU. Make sure QEMU system risk v64 is in a path. Clone the repository bash. Download the toolchain. Okay, Build and run. Make QEMU. Okay. Instruction set. Getting started guide. Okay. Getting started guide. We need to learn. Open the getting started guide. This one. Okay, I got something here. Okay, got the error. Something might be failed while downloading. Clear. Let's try again. Okay, 694. That's good. Okay, 404 not found. 5439 something. Okay, need to update, I think. Sudo apt get update email operation get. Okay, this one. Update. Okay, it's updating. Okay, speed is really slow. Let's explore something here. Getting started, edit with notepad, and I should be able to see something here. LK toolchain, LK work. This guide assumes the following simple layout where your workspace. My LK is the sibling of the cloned LK repository. Okay, under toolchain directory. Toolchain live under toolchain directory in the same parent folder toolchain. LK toolchain my LK. Create a work directory and clone LK. Where okay, git clone. Okay, download appropriate toolchain. This will create toolchain directory under LK work. Scripts. cd lk script fetch toolchain.py scripts prefix risk64 alf. Okay. Add toolchain bin directory to your path. Okay. Find available projects and make the project and we have built a hello app. So it's saying something like we have the projects here. It is project. Sorry, no, projects or projects. I think I got find available project. Okay, ls project star. Okay, and build the kernel. So if I get this and not build targets, we have so many targets here. And if we hello test makefile and we have QEM use ARM64 test. Okay, and edit with notepad, include project Q MK. What ARM64 test MK? Include project. Okay, including the project. What where are the files of it? File system. Okay, scripts. Targets. I think here. Virtual ARM include target. Okay, debug configuration. No, not this. So menu and we have include helio QEMU. No, what am I searching? Okay, we have this app.c. Maybe this is the main file. Let's try to read it. And okay, init void struct destruct app. Okay, I'm not saying nothing. Okay, first download all this, then we will try to build it. Okay, it's already downloaded some and it's still downloading. Well, I will continue the video after it finishes. Let it finish. So finally it's completed now, and we are searching for something else now. So I have completed this. Now if I run the previous command and this one, and it should work now. Let's run it. Have to download says 200 something now at person. And by the time it downloads, let's try to fetch something else, learn something else. So I have these things already we have seen, and I googled uh, that explain the directory structure, and it provided me that kernel is this architecture, is where the architecture or present platforms contain the specific system separate from boards. Architecture contains the process architecture specific code kernel, and I browse the directory called kernel. Here is the kernel, and the kernel generally have these things: timer and threads and port, and how these are managed. And other than that, we have this platform should contain platform specific code, okay, virtual arm. So we are using this, and we have platform.c and Macfiles improved, and there is some more files. We have platform.c. Okay, platform.c. Let's try to read it and try to identify if it starts here. Okay, platform init void, and okay, for oi PCI, sorry, PCI bus. And we have with lib main IP. If virtual net found, net guess MAC address, and these are other things. So these are not the things I'm looking for. I'm looking for something where the code, when the like kernel starts, so it will load which file, and it will load where. So there are some tools to ignoring the tool. I think we need the tool chain, I guess. License, and nothing here. Make a platform and a project scripts. Other scripts build all script and everything. Let's convert it to make something. Like we have platforms where targeting virtual arm. Okay, let's roles.mq. I think here maybe. No, not here. Struggle, not a problem. We have kernel, external docs. Okay, applications and libraries, content users software code, and the top level configuration of the fabric specific binary. So I checked out the projects, nothing so special. And we have virtual arm 32. Okay, let's think of like this for now. QM virtual arm 32, and end of notepad, and nothing. Project's target. Okay, it's including the target. That's it. So that should be target. And give my virtual arm 32. Here is some original MK. I should be able to edit. Okay, okay, project target. Yeah, I'm opening the virtual arm MK. Okay, Virtual MK this one. Okay, target is let's changing to virtual where is Q is anything else? No. Okay, banana API virtual and so that's I think what is it? Init main dot c. Maybe this is the file I'm looking for. Init or main, I think. And okay, primary CPU init label. Okay, not this. So I checked the details and I found something interesting. Maybe might interest you. So it's the main file main.c under top like lk master top, and we have init.c, main.c, and mp.c. Okay, we are under the main.c, and what I found is here include app.h, including the header files, compiler, and everything, and it's below void lk main. This is the main function. I'm guessing, and it's saying then in the Leo line, which is welcome to Little Kernel. So there is something like when we do some compile or something, this file is loading or working. So it should initialize the kernel from here or doing something. So this is one thing, and maybe there's something interesting in it too. So I found interesting in the main notes, so I showed it to you. And flex start level, hs stop level. Okay, CPU calling. No, okay, maybe this could be the another file that immediately required after main.c. So to get us into the some sort of thread context, early architecture stuff. Will keep primary CPU in its level, do any super early platform. So I first we need to build it, then we will try to identify what's going on. Maybe that will be more helpful. So uh, not here, not here. Where is my terminal? Here. Okay, it's still downloading something. Okay, let it download complete. Let this download complete, and we'll continue after that. So welcome back again, and it's still downloading at 16.2 kbps. It's going to take a very long time, I guess. So by the time, without just wasting, I just got that this is the main file. I just searched on Google, and this is how it works. And here is something interesting. I just searched that where's file is that run when kernel starts. So it's the hardware kind of thing. When something starts, when the hardware starts, it first loads the bootloader, then the kernel. So after the bootloader code, it will first run this thing like architecture.start.s. There's some code in there. Let's try to explore this if we could find something interesting. Okay, where is my terminal? Here, still going on 90%. Okay, so and under which we will get this? We will get this under architecture 64. Okay, get this under architecture. arc and ARM 64 or say ARM 32, and we have ARM, what is ARM? ARM mobile maybe, and we have architecture C, cache, exceptions, start.s. Okay, this is the thing, maybe it's starting. Okay, void start void. Copy the data from the ROM and start data start. Okay, data start ROM, data start, data end, and bus start BSS10. Debug compiler mains study end and copy the data from the ROM. Unsigned in SRC destination. While okay, data start and data ROM. LKMN 0000 and 0. Okay, maybe. Okay, there is nothing like .s, right? Systic rules and system and include architecture and h header file, and then we have s. So I didn't got any such files, but I don't know. Include maybe here. Okay, assembly.s and cache.s. Maybe these are already built file, and what are those at .s file. So what are .s? Okay, what are the .s file? Let's search. What are .s files? The assembly language source code file. Okay. It contains low-level, human-readable instructions that are specific to compile the computer's processor architecture, like SSX, ARM, or MIPS. So these are like assembly codes. Okay. So start.s, maybe here. Edit with notepad. We will able to get some assembly thing going on. Start.s, platform reset, and undefined syscall. Okay, start B and FIQ with platform reset and everything. Okay, so what I'm getting here, HYP. If HYP mode, what is move to SVC service mode, hyper mode or service mode maybe. And if let's take if with kernel VM enable cache so automatics. Mm, this is a single block. This is a comment. This is also a comment. Calculate physical offset from our operation left offset. Okay, and here are more comments. Set a menu according to MMU. MMU, what is MMU? Arc has MMU. Multiple memory unit, maybe. Okay, let's try to build it first. Okay, Travis gas solvent, maybe. Sorry to mispronounce. So lgas assembly.h include architecture arm course.h MMU and defines kernel VM if kernel VM. Okay, out of my syllabus. These are going out of my syllabus, seriously. Okay, we got arm thing going on, so we don't need all of this because architecture we don't want to work on at x86, maybe risky. Names are M68K. What is M68K? Some kind of architecture, I don't know. 68 kilobyte, and include we have architectures. Okay, okay, init.c, the main C enter point, which is init.c, and lk main at top init.c. So here everything starts. Okay, so means we have lk master top init.c here, and we have to edit it. So here everything starts, and lk init level void, which is void, and we have target trace index. What I'm searching for is it calls the lk main function located inside. Secret prepares the fundamental hardware environment. It calls the lk main function that top init.c, the file function, as generic architecture independent entry point for the operating system. Okay, I got it. I think it's in init.c. So lk init label, here is a function, and there is nothing, and start. Okay, we got main.c. lk main is in main.c, so this function calls after everything just previous. This function get called. Okay, so after using this function lk boot argument, we are taking save the boot argument. There are up to three to four arguments we can just provide. Kernel init early, get some sort of thread context. Okay, early architecture code, early initialization, do any super early platform initialization, and do any super early target initialization. Okay, and if with SMP, else with SMP, what this thing suggests? Just copy. No, we don't want to cut anything here, and go to Google. We have already have AI, and with SMP, what this line means, what this line means. The line if with SMP is a preprocessor microinstruction to confidential compilation in C and assembly code. A conditional compilation, so not confidential. It tells the compiler to only include and compile the code that follows if symmetric. Multiprocessing is enabled for the target world. What is symmetric multiprocessing? If compiler okay, with SMP according to the variable set little kernel build system, multiple core CPU are enabled, one undefined. Okay, why this used an LK operating system different? Okay, separate cores with SMP is true, with SMP is false. So okay, these are multi-core multi-core processing semantic. I think symmetric multi-core processing. So these are the things I got, and we are still at 97. Let's see where it goes. Hopefully we will able to build something in the future. There will be more videos like this. It's not going to get covered in a single video. Obviously I will try to make it long as much as possible, like an hour, not more than that, but still try to finish as quickly as possible also. So docs and blocking primitives. Okay. So how we will develop something? Docs and VVMM overview, kernel, and okay, we have kernel and this external VM to do.md, LK tab, and getting started, guide, and git clone this. We need to script fetch tool time toolchain.py cd lk scripts py. Do we have the py lk master? We have the scripts. and it should be something called py fetch toolchain.py. Here we have this. We need to run it, right? cd lk scripts and add toolchain bin directory to your path. Uh, appropriate toolchain. This will create a toolchain directory. Why the toolchain is necessary? Why the toolchain is important? Why the toolchain is important? Toolchain is important. A collection of software development tools like compilers, assemblies. Okay, it translates code across a collection plus compilation. So I'll have the build tools. Why I need this toolchain? Maybe I don't know. Let's try to read it. Which toolchains and edit with not one, right? Not one. And in it.c we have what are the toolchains? Arguments, main toolchain hostOS. Install dir. Okay, hostOS, parser. This URL toolchain sort. For toolchain is what the toolchain is a prefix. Toolchains I. Where is the toolchains I? For I range toolchain, line toolchain or toolchain prefix. Version all toolchain. Okay, not toolchain. Something download the toolchain and we'll get the downloads here. Remote toolchains. It sells. Where is the list of toolchains? Bro, I'm not getting the list of toolchains here now. Where is this? Where is the list of toolchain? Install dir. These are the arguments, right? Arguments. Real path dot parent, allocation path toolchain, and parse response URL open not to status response URL live request URL open this URL get the full list of remote toolchains available for the provided host. So here we are making some kind of URL like this URL. Yes, this URL should be text lk root, and these are new OS toolchains. Okay, copy a link. It will be able to find space and go nos.org. Okay, a lot of toolchain REST shell SF x86 spark lk elf iOS mipos maps os i36 arms. Yeah, we will be working on I think most phones have arms. Okay, it's I think it's completed now. Okay, another processing is downloading is completed and it's processing the downloads. So someone might think, why am I doing this? Just for fun, I will say. I have no other things like I'm jobless. So maybe this is how I pass my time. So okay. Toolchain down, upload toolchain. X64 ELF, risk free ELF. I don't want to work on the risk free, so it's not necessary. Our ARM64. So there something should be EABI 64 ELF. Too many things. ELF 4.1, 8.2, 11, 12, FreeBSD, down Linux, down Linux. Okay, I think this is Linux, FreeBSD, and nothing. Okay, let's try to build without a toolchain for now. We will see if it's get going compiled or not. If something goes wrong, we will then download a toolchain for okay, finally it finished. So the next command should be like building for building. Mm, what is this? Command completion. Okay. Building little kernel. So should put it down and make QMO virtual test. CDLK build a upper target option. Compile the standard put it virtual test by excluding make alongside make. Okay. Toolchain if I'm building a non-ARM machine and the build system fails to locate the compiler manually append. Okay, with QA and virtual ARM64 test. Okay, anyway, we know this. So first download the toolchain then. Okay, scrape it, copy CD. I think we'll be able to do this. Else, I think where we are. Scripts, fetch, toolchain script, UI, Python 3, UI THL, Python 3, Python. Then we'll be able to risk. Oh, sorry, Control C. I don't want it to risk 64 ELF. ARM 64. I think ARM 64 is also right. ARM 64 ELF. Yes, ARM 64. ARC, not ARC. I want just ARM. ABI. ARM 60. ARM ABI. ARM EABI. Okay, it's doing maybe doing something. I'm not getting any idea for it. It's not showing me any output. I'm not sure the Python is installed. Okay, downloading. Okay, it's showing something. Downloading EABI 15.2.0 Linux x64 to okay. It's working. It's working. Okay, I think we should leave it idly and focus. Okay, we need to virtual test compile. Make QEMU virtual on 64 test. Okay, next we need to have the make command. So I'm waiting with this. How big it is? how big it is. Which is downloading on EABI 15.2.0 on EABI 7 at 12, 13, 14, 15.7 of 64 Linux Arc64 architecture. Linux x64, Linux x64. This one is 68 megabytes. Okay, I think we'll be able to download from directly. Let's try. Okay, it's gone super slow. I admit. Okay, so let's wait for it to download and we will continue again after this. So it's been an hour now and the screen is stuck at here. I don't know, I have already downloaded the file. Here you can see. Maybe I should extract and work on it. Let's try to do that. Let's try to make it first. First, cancel it. I don't want to waste my time here. Clear. And we have to make. I think that's the command. Okay, make QA virtual test. Okay, search, not search, copy, and I should be able to do it right. And make directory GCC error 2. Okay, that's some errors which I need to resolve. Okay, we will continue this in the next video. Hope this video finds you well. Thank you.